Hey guys, and welcome back to my channel. Today we have an exciting topic for you. We're going to dive deep into the world of machine learning and understand the top 3 common machine learning algorithms in a way that's easy to understand. But before that, if you're new here, make sure to subscribe, turn on notifications so you get notified every single time I upload a video. Before we get into the algorithms, let's start with the basics. So what is machine learning? Well, machine learning can be considered as a subset of AI that focuses on the development of algorithms that can learn from and make predictions or decisions based on data. And in this video, we'll be discussing about the top 3 common machine learning algorithms. The third one is logistic regression. So, logistic regression is a statistical model used for binary classification tasks, where the goal is to predict one of 2 possible outcomes, which would be 0 or 1. It estimates the probability of the binary outcome based on one or more predictor values. So, for example, consider a logistic regression model to predict whether a student will pass, which is 1, or fail, which is 0, in an exam based on the number of hours they studied. So, the model calculates the probability of passing as a function of the hours studied. So if the estimated probability is greater than a certain threshold, let's just take it as 0.5, so the model predicts a pass. Otherwise, it predicts a fail. So in this scenario, the dependent variable, which would be pass or fail, and the independent variable would be the hours of study. So logistic regression is widely used in fields like healthcare or finance and marketing. So these are where binary decisions are crucial, and it's a valuable tool for modeling and understanding the relationships between the input features and the binary outcomes. Now let's discuss about the second algorithm, which is decision trees. So decision trees are popular machine learning algorithms used for both classification and regression tasks. They work by dividing a data set into subsets based on different attributes, allowing for the creation of a tree-like structure to make decisions based on the tree. For example, consider a decision tree for classifying fruits. So the root node might split the dataset based on the color of the fruit, with branches for yellow and not yellow. So each branch represents a decision based on a specific attribute, and the process continues further, dividing the data into subsets until a final decision or classification is made. Decision trees are easy to understand and are suitable for a wide range of applications, from medical diagnosis to customer churn predictions. They're especially helpful when you need to explain the reasoning behind a decision, making them a valuable tool for transparency in decision-making process. Now let's discuss about the first algorithm, that is linear regression. So, linear regression is a statistical technique commonly employed in both machine learning and statistics to establish a relationship between a dependent variable and one or more independent variables. This is achieved by fitting a linear equation to the available data, enabling us to predict how changes in the independent variable would impact the dependent variable. For instance, let's consider a real estate agent aiming to predict house prices based on a square footage. So in this case, dependent variable would be the selling prices of houses, while the independent variable would be the square footages of the houses. So first you gather data on house prices and the respective square footages. Then you calculate a line that minimizes the prediction error. Finally, you formulate an equation that predicts selling prices based on those square footages and use it to predict house prices. This method can also extend to multiple independent variables in cases where more factors influence the dependent variable, which is known as multiple linear regression. So, linear regression is used in medical research to analyze the relationship between variables such as age, weight, or blood pressure and other health outcomes. And it can also be used to analyze the relationship between variables such as stock prices, interest rates in the finance sector. And that actually brings us to the end of today's video on the top 3 machine learning models. If you found this video useful and if you're able to grasp the 3 concepts, make sure to share this video, subscribe to my channel, and hit that like button as well.